Yesterday we talked about interior angles in polygons. Today we're talking about areas of polygons. However, there's a key word in the title. Areas of what kind of polygons? Regular. What does regular stand for? All sides are equal. All angles are equal. Hand in the air. What's the vocab word for all sides equal? Kaden, what is it? Equilateral. Perfect. What's the vocab word for all angles equal? Caitlin, do you know? Equiangular. Good job, good job. So what I'm going to show you today is how to find the area of any equilateral triangle, so all sides equal, and then any regular polygon. We're going to find the area of it. There's formulas. They're kind of, one's fine and the other one's like, yikes, a little bit. I'll show you. Okay, this part, you guys, I know, you feel like when teachers put stuff up, you feel like you have to write it down. Do you have to in this class? No. Absolutely not. So just read it, and then you can draw your picture, or just like a duh, it's already there in the name of it. So the first one, center of a polygon. So right here, I put a polygon up here. This is the name of this shape. Hexagon. Good job, it's a hexagon. So the center of this hexagon, center of its circumscribed circle, it's a little bit tricky, so I put a circle up here. It might not match perfectly. Circle vertices touch the edge of the circle. Yikes, it's close but not quite. Right? So the center of this is the center of the circle. So if you just want to sketch yourself one, I kind of feel like it makes sense anyway. It's the center of the polygon, right? So it's a point right smack in the middle. Okay, well, the radius. Radius always corresponds with circles, right? Radius is a circle vocab word. So the radius of the polygon is the radius of its circumscribed circle. So just go from the center of the circle out to the edge, and that's the radius. Right? Again, I hope that makes sense. You're going to have a circle around the polygon in order to get a radius. This third one on this page is killer for this section. This is the most important vocab word. It's called apothegm. Okay, will you try to say it? What is it? Apothegm. Say it again. Apothegm. It's like you're saying opossum, but you have a lisp. Apothegm. Yeah? So apothegm of a polygon. This one, let's definitely draw a picture of it because it matters. You're going to need whether it's an apothegm this up. Okay, it's the distance from the center of the polygon to any side of the polygon. So I've got a polygon, hexagon, right? Check this. From here to here, is that an apothegm? Yes. From the center to the side, yeah? So it's usually labeled with a little guy A. Question then, what about this blue chunk? Is this an apothegm? It's not, right? Because that's going from the center to a vertice. Apothegm has to go from the center to the side. Be careful, yeah? I'm trying to think if I want to tell you anything else about apothegm. Apothegms are usually, well, they are 90 degrees to the side of the shape. It's convenient because we had a whole chapter on right triangles. We're going to use all that right triangle knowledge. You might need a refresher. Okay, last vocab word. Okay, stop and just look at it. Central angle of a regular polygon. All right, so where does that angle have to come off of? That's it. So really, do you need to write that down? No. It's just the center of the polygon. It's an angle coming off of the center. I feel like it's right in the name of the vocab. Okay. So we've got center of the circle, and the angle coming off of it. The vertex is the center, and its sides contain vertices. So like, check, check. That's a central angle. If you want to sketch it, go for it. Don't stress too much. The main focus of today's lesson is apothegm. Can I say it again? What is it? Apothegm. All right, here comes our first formula. I don't mind this one. I can follow this one without too big of a problem. The first formula is for equilateral triangles. What kind of triangle? Equilateral. So equilateral, what can you remind us? Sides are all the same. So here's the formula. 1/4 times the square root of 3 times s squared. Write it down and we're going to use it. What I see students do with this formula is they try to square everything. No, don't square everything. What's the only thing that's squared? Only s. It's like this. Everything's getting multiplied, so it's 1/4 times the square root of 3 times side squared. So if you want to break it down so you remember, go for it. Now the CRT, it usually bounces back and forth between the answers that are just decimals and answers that have radicals, like square root of 3 in them. So let's just put both so we're practicing. Because I think the next part of your notes, top of the next page, is an example of this. Alright, formula, here we go. Let's use it. The says, find the area of an equilateral triangle with 12-inch sides. Do yourself a favor and draw a teeny tiny sketch. So just saying we have an equilateral triangle, all sides are 12. Well, if it's equilateral, then we can use that formula we just wrote down. So the area is going to be 1/4 times the square root of 3 times the sides squared. Alright, in this example though, what are the sides? 12. Alright, so we have to square the 12. It still happens. People are still doing 12 times 2. Does that mean 12 times 2? No. 12 times what? 12. Alright, so 12 times 12. So we have 1/4 times the square root of 3 times 144. Okay, stop. I'm going to help you out. Okay, what if it's CRT time and you look at the ABCD choices and they're all radicals? They all have square root of 3. Alright, here's how you deal with it. You've got to do 1/4 times 144. But there's an easier way. Because 1/4 times 144 isn't that the same as 144 divided by 4? Do it. Combine those two first. So grab your calculators and do 144 divided by 4. 36, we agree? Alright, so your final answer, don't forget the square root of 3. Final answer would be 36 square root of 3. Now we're finding area, and it said inches right here. So 36 square root of 3 inches squared. Did I lose anybody on that? Okay, let's change it to decimal just for the practice. So grab a calculator. Type in 36 times the square root of 3. And then raise your hand and help me out when you have it. Ooh, Tyler, what is it? It's like 62.25? 35 square inches. Either one is totally appropriate. We'll do both for the practice. Alright, our very first formula, how do you guys feel about it? You okay with that formula? You okay? Alright, let's practice again. Okay, number 1, not too bad. I'll rewrite the formula for you. Number 2, a little bit messy, but I want you to try both number 1 and number 2, and then we'll come together and help each other. Get a good head start on it. Okay, so the first one, the sides are 6, right? So 1/4 times the square root of 3 times 6 squared. Guys, what's 6 squared? Okay, did you, oh man, I wrote 30 down into a radical answer? So take the 36 and just divide it by 4. So what's 36 divided by 4? Alright, so final answer could just be 9 square root of 3. Oh! Teaching, let me teach you something. Units, there's no inches, miles, feet, whatever. So you just put units squared. If you don't want to write out the words units, you could just put a U for units squared. Curious, how many of you got that part? Did you get that part? Did any of you change it to a decimal already? Do you mind helping me out with the decimal? Christian, what'd you get? 15.58? Square unit? Ooh, what's that rounding? 5, oh, huge eraser. So 15.59? Nice. How many of you got that one? You okay? Alright, number 2, it got sloppy. Did you notice? You gotta be careful with the squaring, right? So the very first part is just the same. So 1/4 times the square root of 3 times, be careful with this, 4 square roots of 7 squared. Okay, the square does get rid of the square root, but it does something to the 4 also. It's kind of like the distributive property, where this 2 has to be tagged to this and to this. So, square them both. Guys, what's 4 squared? Okay, so 16. And this is what Ellie was talking about. What's the square root of 7 times the square root of 7? 7. So, that's really 16 times 7. Did any of you remember that? It's been a while since we've done one, yeah? And then you just bring along the other stuff. So we still have 1/4 and square root of 3. Okay, leave the radical 3 alone and just deal with the other ones. So you could do 16 times 7 divided by 4. Check technically, what's 16 divided by 4? Right? And then 4 times 7? Yeah, I agree with you. It's totally 28. So 28 squared to 3, same thing, unit squared. Did any of you get that before you're on the board? Oh, really? That's amazing, that's amazing. Good job. Has anybody changed it to a decimal yet? Do you mind helping us? Ellie, what'd you get? 48.50? We'll put 0.5 units squared. Did I get the same thing? Do you agree? Jane, question?
Can you just like simplify the rad?
Yeah, absolutely. I would totally work. You okay with these ones? Alright, let's see what's next. Big one? Yes. Dun dun dun. It looks not too bad, but it takes a lot of thinking. Copy down the formula. This is the area of any regular polygon. Regular hexagon, regular pentagon, regular octagon. This will work for anything as long as it's regular. And then heads up, I'm going to stick with the first version because that's what's shown on your reference sheet. So I want to make sure you understand what these are. And this is what's on your reference sheet. All right, guys, let's break it down. You got this. What does capital A stand for? Okay. What do you think little lowercase a stands for? Yes, say it again. That's the apothem, so be careful. Apothem goes to the side. And then what does the capital P stand for? Yes, perimeter of the shape. It's not always super easy to find the apothem in the perimeter. It's doable, but it's not always super friendly. So we're going to do these together. Deep breath, are you ready? Okay, are we flipping the page, top of the next page? All right, I think I skipped, yep, pretty dang sure I skipped that top one. So we're going to go to the bottom two in your notebooks. Now there's room, but heads up, write small. These actually take a lot of work, so write small. Tell me if I'm going too fast. You definitely want to get the steps down so you can look at the steps as a reference when you're doing your homework because they'll be kind of the same. All right, here we go. Number 3, bottom notes, you with me? That 8, oh, first, what shape is that? Hexagon, right? Okay, that 8, is that an apothem? You're right, it's not. So let's draw in the apothem. So we need this piece. Let's just put an A there for apothem. Okay, we also need the perimeter. Do you agree with me? So let's put a little X here. We need A and we need X. Oh, where do we even start? This goes into what we learned yesterday with the inside angles. So this shape, all of the angles added up together equal shrug. Do you have that formula memorized? Me neither. Do you remember the trick that I showed you though? Break this up. Could I break this into two four-sided shapes? This up here, all the angles added up equal what? Okay. So all the angles down here equal. Add them together, so all the angles together equal. Okay, so write it down. I need that. All of them together equal 720. But we just want one of them. If it's a regular, they should all equal the same thing, right? So how can you use 720 to find one angle? Tyler, what would you do?
Divide by the number of angles.
Perfect. So divide by 6. 120? Okay. So let me show you what you just did. You just found one of these angles. Like that angle is 120. All the rest of them are also 120. You with me? Okay, why? Why are we doing this? Because we need one of these angles. This whole thing right there is 120 degrees. But for that right triangle, we only need a part of it. So that bottom right corner get measures. It is, Tyler, it's 60 degrees. Cut that in half. This right here is 60 degrees.
Wait, oh, we know what's in half.
If that one's 60, what's the top angle? 30. Okay, write it in. It's a 30, 60. Remember our chapter on 30, 60, 90? Yes. Well, Ellie's question, do we have to remember? Yes, because you're going to need to use them. However, it's on the reference sheet. So you can be like, ah, crap, the 30, 60, 90. Go to your reference sheet and I'll walk you through it. When you go to the reference sheet, It'll say something about the hypotenuse. The hypotenuse is double one of these sides. Do you remember which one? It's the x. It's the one across from the 30. And that's on your reference sheet. So hypotenuse is double what's across from the 30. So x would have to be 4, right? All right, let's sneak it in. So if x is 4, no, just that piece of the triangle. We'll need x to find the perimeter. Okay, back to your reference sheet. You're like, oh crap, I don't remember. Does anybody remember across from the 60? Do you remember how to find it? Christian, do you remember? It's x squared of 3. That's perfect. So what would it be for our triangle right here? 4 squared. Guys, I can't believe you remember. That's amazing. 4 squared of 3 for A. Oh man, do you have this down? Are we going too fast?
Wait, what are we, so we're just trying to find the area, right?
Well, we found the apothem. Now we found a piece of the perimeter. Let's do the entire perimeter first. Because what we're doing, Ellie, is we've got our formula that's area equals half the apothem times the perimeter. So now we've got the apothem, but now let's find the perimeter. Okay, let me change up the colors. If this piece is 4 at the bottom, what's this whole piece? So this side would also be, right? So the perimeter is going to be what? Perfect. You've got 6 sides, each of them are 8, so the perimeter is 48. Heads up, on your assignment, there's questions where you have to do both perimeter and area, so might as well just write it down. Okay, now for the area formula, let's just stick it in. So area equals half the apothem, which we found was 4 squared of 3, times the perimeter, which we just figured out, 48. All right, write it down. I hope you're giving yourself some room. Same as we just did before, use your calculator and do everything but the square root of 3, and let's leave it in radical form. So I think of it as half of 4 is 2. 2 times 48, isn't that just 96? Anybody back me up on that? Right here, we've got this. We can combine these ones. So half of 4 is 2, and then I think 2 times 48, 96. And then slap on that square root of 3. Do we have units in this one? Nope. Units squared. Or, grab your calculators, type it in, get the decimal form. 0.28. Thanks, guys. Ay, ay, ay. Tons of review in one question. Go ahead.
So, does it always end up being the square root of 3?
It's a great question. Elias, is it always going to end up as the square root of 3? No. I think number 4 is not a square root of 3 problem. It just matters what your angles on the inside of your right triangle equal. Let's do another example. Any other questions on number 3? Okay, I'm curious. I know this is heavy. I know this is our first example, but with your thumbs. Thumbs up, I'm pretty sure I got it. Halvesies, I got most of it. Downs, yikes. It's okay. Don't worry. Don't worry. Perfect. Thank you. I appreciate it. Here we go, number 4. Are you ready? Number 4, I think I have enough room. I'll just write small again. Number 4, look at it. That 12, is that the apothem?
No.
Let's draw in the apothem. So, where do we want to put it? Here. 90-degree angle. Here's our apothem. We're going to need this piece, so let's call that piece X. Okay, first we need to know the interior angles. What's the name of this polygon? Pentagon, because it has how many sides? 5. So if we got all the angles added together, do you remember the trick? Split it up. Sure. So in this piece, the triangle, what do all the angles add up to equal? Okay, and this top piece, what do they add up to equal? Okay, add them together. 540. I'm going to go back. All together they're 5, but we need one of them. So how do you find one of them? Perfect. Isn't that just... Oh, okay. Okay, what you just did is you found one of them. For example, like this one, 108. Okay, so up here, this is 108. But we don't need that whole thing, right? What's half of 108? Okay, so that top angle at the right triangle. Okay, Ellie, go ahead, question.
So couldn't you take the 12 because you know it's because of the circle and draw.
Okay, you okay so far? Now that picture is tiny. I almost want to redraw it. I'm going to redraw that triangle. Are you ready? So we've got this triangle with 12. So it's like this. Here's apothem. Here's the 90 degree. Here's x. Here's 12. 54 degrees is right here. What a terrible triangle. Okay, here we go. This is not one of our specials, right? 45, 45, 30, 60. But there's still ways to find the sides from another chapter. Alex, do you remember? Yes, Alex, thank you. We've got to use sine, cosine, tangent. Yay. Right? So much review in one question. So let's start with, you know, I'm not happy with that triangle. Because it might be hard to tell which is which. All right, let's redraw it. Nice straight lines. So 12 is here. Is A, oh, X is here, A is here. All right. Where's the 54? Right here. Which trig function will use 54 as a starting point, A and 12? Start at angle 54.
No, fine. Yeah, you
Did I? Are you sure?
Yeah, well, it's right, and then flip it, the A should be on the bottom, the X should be there.
Are you sure?
No.
I kind of feel good about my picture.
Still opposite of
Okay. I think we're good. Because I think the X is our bottom piece. X the bottom piece. Okay, I heard it, guys. Which trig function is it? Sine. Are you ready to write it down? It turns out not too bad. So we have the sine of 54 degrees equals opposite over hypotenuse, A over 12. Okay, how do you get rid of that divided by 12? Times by 12. So we'll have A equals 12 times the sine of 54. This one's nice because we're just going to leave everything in decimal form. Okay, make sure you write this down because you're going to want to follow your steps later. Okay, does anybody have that yet? 12 times the sine, what'd you get?
9.71.
All right, let's just do 9.7. You okay with that? All right, 9.7 for the apothem. Okay, we're going to use that for our formula. Do you have it? Now we've got to find x. Okay, so if you start at angle 54, which trig function will use x and 12? I heard it. What is it? It is cosine. Okay, so let's do the exact same setup. Start at 54, but use cosine. Cosine of 54 is adjacent over hypotenuse, x over 12. So what are we going to times by on both sides? 12. So we've got x is going to be 12 times the cosine of 54. I feel like x is smaller, but I can't remember the apothem. 7 point what? 05. Should we do 7.1 then? Okay. Whew, bless you. All right, you got this? We're almost done. Stay with us. Now let's do perimeter first. Are you okay with that? What you just solved for up here in the picture is this. This piece is 7.1. So let me change up the colors. What's this whole side then?
14.
Yay! 14.2. So to find the perimeter, do 14.2 times what? Do you know? Yeah, times 5, because there's 5 sides. Should come out as a whole number. 71? Convenient. Question, Brett?
Should you just do 7.1 times 10?
Sure. Totally could. Great question. All right, so we've got perimeter. I'm going to box it. We're proud of it. Move a little bit. Hopefully this will work. Okay. Area formula, 1/2 apothem perimeter. We are almost done. All right, area, 1/2 times, what was the apothem? We already solved for it. 9.7 times the perimeter. What did we get for perimeter?
71.
Grab your calculators. All we have to do is type this one in. Thankfully. All right, so 0.5 times 9.7 times 71. 344.35. Was it already up there?
Yeah.
Left over. Units squared. How many of you were able to fit it in your notes? Were you able to fit it? Yeah? Thank you for writing it down.